The first step in understanding how someone can be injured during a crash is to see what happens during a rear-end collision. The best way to do this is to study crash test footage involving live human test subjects. We're going to look at live crash tests of two different speeds. The first one is a 3.9 mile per hour crash, and the second is at 6.3 miles per hour. These are considered very low speed collisions, and many collisions in the real world are at much higher speeds. Live occupant tests are not done at higher speeds simply because they are not safe for volunteers. First, we'll watch the cars from the outside as they collide. As you can see, the occupant motion takes place very quickly, in about 1/10 of a second. Let's change our view slightly and see the effects on the occupant during the crash. First, we'll watch the impact at its actual speed. As we can see, the occupant is exposed to very rapid accelerations. In fact, in this collision of just 4 miles per hour, the occupant's head experienced 5 Gs of force, comparable to what a fighter pilot might experience, but without any protective equipment, and this is from a collision of about walking speed. Now, let's slow this crash down so that we can see the details of the occupant motion. As we can see in this video, the car is accelerated forward, pushing the pelvis and torso forward with the car seat. Since the occupant's head is not in contact with the car, it lags behind the body until it hits the head restraint. Finally, the head rebounds forward in the direction of the car's motion. Remember, this is a collision that took place at less than 4 miles per hour. Now, let's look at a collision just a bit faster, 6 miles per hour. First, we'll watch the crash from outside the car. We can see that the force is dramatically greater on the occupant in this collision. When we move inside the car, we can see that although the speed of the collision is just slightly faster than the first crash, the occupant forces are much more dramatic. When we slow down the crash test, we can see the same body motion as before, but the accelerations that the occupant experiences are much higher. In this crash test, the occupant experienced 9 Gs of force, almost twice that of a 4 mile per hour crash. So, though the speed only increased by 50%, the forces on the occupant doubled. To demonstrate how this can result in injury to the neck, let's look at it this way. The human head weighs about 10 pounds on average. When accelerated to 9 Gs, the human head effectively weighs 9 times its normal weight, or 90 pounds, and all of this occurs in just a fraction of a second. As we'll see in the other videos, it is the rapid acceleration of the head in relation to the torso that results in whiplash injuries.